Hi, I'm Matt, the training manager for Redland, and I'm going to talk you through how to put together a full metric roofing system. So before starting to work with your roof, you need to understand the basic shape and the names of the details, the terminology that's involved in the roof. It enables you to understand the installations that we put in place on there. So this roof is a basic gable-to-gable roof. The gable refers to the large triangular formation at the end of the roof, and you've got a gable here and a gable at the other end, hence gable-to-gable. Also called an up and over or a duo pitch roof, talking about the two pitches to the roof. On this roof, we've then got various details. For example, towards the eaves, so we have our eaves. The edge of the roof on this gable, we call the verge. And at the top of the roof, we call that the ridge. The pieces of timber that we'll be working on this roof, which everything is attached to, are the rafters. So the rafters run along the length of the roof with our eaves, verge, and ridge. One more piece of information that's important to know, one more bit of terminology, is the word pitch. Pitch refers to the angle of the roof. It can be a higher or lower pitch, and that roof pitch will dictate what product you can then put onto the roof. Get that wrong, and either the tiles are coming off or the water's going in, which is really what everything is about when thinking about putting products onto your roof. As you're about to see, putting a roof together is one of the most complicated parts of our building, but the tools you'll need to do that are not. First, we have our basic tape measure for measuring out and marking out the roof. A chalk line for creating straight lines, pinging a line across the roof and allowing us to mark out where our lines of tiles and battens are going to sit. A claw hammer for knocking in the nails. And then finally, our drill for our screw fixings. There are a number of ways to ventilate our roof, and Redland supports the installation of low-level and high-level ventilation on the system. And that's the first thing we'll be installing today, our low-level ventilation to allow air to flow into the loft cavity, to circulate and prevent condensation in the roof area. So the first product we'll be installing today is our low-level eaves ventilation. And we'll be doing that by installing what we call a rafter roll, part one of a two-part system which will be installed across our rafters, across the roof, and will guide the air up into the loft area at a height of 800 mil. The reason for that is it needs to come out above any pre-installed insulation that's there in the loft. If the insulation comes out above the lip of this tray, it will block the airflow and cause condensation in the loft area. So we position the roll on the left-hand rafter there, and fixing it top and bottom, carefully roll the rafter out across the roof. We don't need to worry about the corrugated shapes falling exactly on the rafters themselves. That's not necessary, as long as we haven't got too much drape in between those rafters. Another thing to guard against is as we're rolling out the material, make sure we don't pull it too tight. We want to maintain that corrugated shape throughout the roof, so it allows the air to flow up into the system. You can tack it into place and then trim it off to finish at the end rafter. So the second part of our low-level ventilation system is a purpose-made underlay support tray. It's a purpose-made tray with an integrated grille underneath. This allows the air to flow up and into the system and also protects the system from any debris from being blown up into the roof. We've got lugs set alongside that grille, which position above the fascia board on the roof so we know where to fix the tray onto the roof. As I said, they interlock, so you haven't got to worry about the laps of the trays, the side laps. They'll actually interlock together, and then we're just trimming the system off at the end of the roof. What this is there to do, besides allow the air to flow up into the roof, is also allow our underlay to sit on top and prevent it from sagging into the roof cavity and allowing moisture to flow into our roof and causing problems with damp. We position our first tray flush against the edge of the barge board on our verge, making sure the lugs underneath are sitting over the fascia board. Those lugs need to sit centrally over the fascia board so those fixings will go straight down into the timber and hold the trays in place. Once we're happy the system's in place, we can then fix it in, make sure we don't miss any of the fixing points. This is our first point of access onto the roof and it needs to be sturdy. We're fixing the system in place today using a 60mm alloy nail. So we want to make sure we're fixing into every one of those lugs going across the fascia board. As we move along, we interlock the trays. There's a male-female connection there. We put them together as we go through, again making sure the lugs sitting above the fascia board and fixing them in place. Because they're interlocking, when we get to the end of the roof, we'll most likely need to make a cut and create a small piece of the tray to fill in the end of the roof to sit against the far barge board, where again it will sit flush against the edge of the roof. Now we're happy that our eaves is well ventilated, we can get on and install our underlay system. So what we're using here is what we call SpearTech 402S. It's one of the Redland's top of the range underlays. It's a 4-part vapor permeable system. It means it's very strong. It can be used anywhere in the UK. The reason we're concerned about that is under BS 5534, the standard for roofing, we now have what we call a zonal fix for our underlays. So there's a badge on the product which tells us where our underlay can be used in the UK. You can't use every underlay everywhere. You need to check the badge and make sure the material is appropriate. SpearTech can be used anywhere in the UK with any tile at any pitch. What we're trying to prevent is what we call underlay ballooning, is where the wind load gets onto the underlay, pulls it up and really hits the back of the tiles and causes the roof to fail over time, especially on the horizontal laps where they can burst open and cause quite considerable damage to the roof in one go. And for that, we've got an integrated sticky strip. So at the top and bottom of this roll, you can seal the horizontal laps and prevent the underlay from moving and again causing our roof to fail. So to make our lives easier, we've placed a batten along the length of the roof, and all this is going to do is allow us to roll our underlay across the roof space without it dropping in between the rafters. So we'll place the underlay flush with the right hand side of the roof, again flush with that barge board on the right, roll it out. We've created a fixing point. We've used just a standard 15mm felt tack, pop that in on the top right hand corner on our right hand rafter, and then roll the underlay out across the roof to fix it again on the left hand rafter on that side of the roof. As we're installing it, we get to the left hand side, we want to pull it tight, then release to allow some slack back into the system. You need to have a nominal 10mm drape between your rafters. This is to allow liquid to flow beneath the rafters and down the roof. Without that, what you create is something akin to a snare drum, and that will stop the water against the battens. The battens will then get moist and rot, and even worse in the winter, you can get frost damage on the roof. So always ensure you've got that nominal 10mm drape to allow liquid to flow beneath the battens when they're installed later on. Because we're using a ventilated ridge system, we need an open ridge. We need some airflow to come from our eaves and through our ridge system. So what we do now is we cut the underlay back. We cut it back by 30mm, and that 30mm is taken from the manufacturer's fitting instructions for the ridge system, so it will change from manufacturer to manufacturer. So we cut the underlay back 30mm from the apex of the roof, ensuring the bottom edge of the underlay is lined up tape to tape with the piece beneath, the pre-installed piece. Because we've already sorted out our laps and our drape on our underlay, the next piece will follow that natural drape across the roof, so you've got your 10mm drape already in place. We cut our piece to size, again tack it into place, top right, top left. We've then got the tape to deal with. Now do not pull the tape out all in one go, you'll make a mess of the roof. It will just stick wherever you pull it out. So go to the verge of the roof, pull out the corners of the tape, pull it straight down and then pull the two pieces together and smooth them out like so as you move across the roof. Don't worry if you get kinks in the underlay. You're installing this over an open rafter, so the material may kink a little bit. That actually doesn't matter. What we're not looking for here is airtightness. We're looking for a strong fix. And as you'll see, once those two pieces are stuck together, they won't come apart. You literally have to destroy the material to get those integrated strips taken apart. So what we should end up with is our pieces of underlay sealed together on the roof with a 30mm gap close to the apex of the roof, allowing our air to flow up into our ridge system. So today we'll be fitting our landmark double Roman tile. It's in a terracotta brindle, referring to the colour, and the landmark refers to the slurry paint on top. It's an interlocking tile, so they are locked together on the roof, and they're around 10 to a square metre, 9.7 tiles per square metre, which is why we refer to them as a metric or a large format concrete tile. It's important to know what tile you're using because that will dictate how it's used on the roof. So we're going to look at batten gauge, which is the distance the tiles sit apart on the roof, and we're going to use our Redland pocket guide to find our measurements for the landmark double Roman. The method we use to work out the batten gauge works for almost every tile in this book. The numbers change from tile to tile. The information can also be found on our website, and you can get this book from any local roofing merchant. The first thing we need to do is find our first fixed point on the roof. That's where the top of our first batten will sit on the roof. So the way we do that is we look into our books and find the hanging length of our tile. The hanging length isn't the full length of the tile, it's the distance from the bottom of the nib to the bottom of the tile. We take our hanging length, which in this case is 397, and we take off 50mm. The reason we're doing that is because our first tile will overhang the roof by 50mm to allow any offlow of liquid into the gutter. So we've got a hanging length then of 397 minus 50mm, giving us our first fixed point on the roof of 347, and that's where the top of our first batten will sit. Every tile has got a minimum and maximum gauge. For a double Roman, that's 343 at maximum and 293 at minimum. So the distance those tiles can be apart from the top of one batten to the top of the next. If you take a tile above or below the minimum and maximum gauge for the tile, that tile will fail. It will expose the nail holes and it will allow wind-driven rain to get into the roof and cause the tile to fail and the whole roof system. So our next point is to work out our top fixed point. Our bottom is 347, our top is 45mm down from the apex of the roof. Again, this measurement's taken from the ridge system, so you need to look at the manufacturer's guidance, and in the Redland instructions for the ridge system we're going to install, you'll find the top of the last batten needs to sit at 45mm down from the apex. So we'll mark that out. The next step is to then measure between the first and top fixed point on the roof to get the space in which we're going to be fitting our battens, which for this roof is 1300mm. Now we want to find out how many courses of tiles will fit between our bottom fixed point and top. So we divide the 1300 by our maximum gauge, which is 343. When we get the answer to that, we round it up, which gives us 4 courses of tiles. So measuring up 4 times to reach that top fixed point from our first. And to find out how far they are apart, we simply divide the 1300 by 4 to give us our gauge of 325. And as we can see, we're quite happy that sits in between our 343 and 293 max and minimum gauges. We repeat this process on the other side of the roof to square off the roof so we can ping our lines across with the chalk line and fit our battens onto the system. Having marked out our fixed points on both the left and right side of the roof, we then use a chalk line to strike some straight lines across the roof. We don't just want to use markings on the roof because we want a clear line of where the top of our batten will sit. No piece of timber is completely straight, and without that line you run the risk of the batten becoming curved on the roof under the weight of the tiles. So we've installed our low-level ventilation so we can get our air flowing into the roof space. We've put our underlay on top of this, and then we've marked out where the tops of our battens are going to sit on the roof. So we know on this roof we're going to have 5 battens leading up to our ridge. And it's time to install the roof batten. What we've got here is a 25 by 50 mil metric batten. It's a standard batten size for roofing with large format concrete, and you really don't want to stray away from that. Graded timber on 25 by 50 is the way to go. Very important to use the right size timber, because all the roofing system you're going to put on top of this is designed to work with a 25 by 50 batten. And if you don't use the right size timber, that roof will fail. Using the lines that we struck earlier as a guide, we're now fixing the battens with the top of the batten touching the line. Starting with our first batten, we fixed them with 60 mil alloys, and we're hammering those nails into every rafter along the roof. This is a load-bearing structure. Our tiles are going to sit on this. We need to make sure the timbers are the right size and they're well secured. As we move along the roof to the top, we make sure we don't install our top batten yet. We need to leave that one off, because the next thing we're going to do is install our ridge batten strap. And if we install the top batten now, the ridge batten strap won't be able to go in place over those rafters. On the left hand side of the roof, we've left a 60 mil overhang so we can install our dry fix verge system. On the right hand side of the roof, we've kept the battens nice and flush with the side of the roof so we can install a concrete fitting as an alternative. With all of our battens in place, except for the top batten, we now turn to our ridge kit, our dry fix ridge kit. And we take out the batten straps, folding them like so. Always fold these away from the roof and then offer them up. If you try and fold it over the batten on the ridge, it'll just turn into a curve and it's difficult to get into place. But the batten strap will now hold on to the apex of the roof and hold our timber in place for a mechanical fixing for the ridge system. Again, referring to the Redland handbook, we find out what height the ridge batten needs to be. In this case, for a double Roman, we need a 50 mil upstand. So what we're using here is 2 38 by 25, what we call a plain tile batten. Putting those on top of each other and using the batten straps to pin that down to the apex of the roof. So we're pre-folding the straps, putting them over the batten and fixing them either side of the rafter, really levering those nails in either side so we don't pull it one way or the other. Once we're secure, we fix one of those to each rafter all the way along the roof and get a nice secure fixing on which we can then put our top batten. So our top batten goes in place now, and that offers yet another fixing on top of that batten strap to hold the ridge secure. This is absolutely vital because this is where the entire ridge system is then fixed into the roof. And if it's not secured properly, you're risking a serious roof failure. Much of the time in roofing, most of the work is in the setting out. We've got our batten gauge sorted, we've got our underlay in place, we've got our ventilation in place here on the roof. We're ready for our ridge system, and now it's time to start putting some tiles onto the roof. So to do that, we're first going to put our first course of tiles in its entirety. On a small roof like this, it's the best thing to do because it allows you to see how those tiles are going to sit onto the roof and allow you to adjust the tiles to fit the roof space. Every tile has what we call a 3 to 5 mil shunt, which is the amount the tile can move across the interlock. And we're going to use that now to allow the tiles to fit the first course of the roof. When fixing our tiles to the roof, we need to have a minimum of 1 fixing per tile. That's a nail or clip, and then 2 fixings per tile around all of our perimeters. So on our verge, eaves and ridge, and around any other perimeter on the roof, such as windows, chimneys, any separation in the tiles, we have 2 fixings per tile. On our eaves, that means installing a nail at the head of the tile and an eaves clip at the bottom of the tile, which hammers down straight into the fascia board. We always tile right to left on a UK roof because of the placement of the interlock on the tile. So for every verge on the roof, you'll need an eaves to ridge closure pack. What this does is closes off our dry verge system at both the eaves and, as we'll see later, at the ridge. This part is installed over the edge of the tile and is either screwed into the side of the barge board or fixed with a clip to the top of the fascia. We're happy now with the sit of our tiles on the roof. We know how they're going to be placed. On a larger roof, we might want to work this out in blocks and strike some lines up the roof to keep our tiles in line as we lay the rest out. But on a small roof such as this, I think we're happy just to lay the tiles out now. And as we come to this end of the roof, we'll install our verge units. Now this is our ambi-dry verge system. It's called ambi-dry because you can fit it on either side of the roof, both the left and the right. You don't need two separate packs. All you do is take a look inside the unit and it will say here for left hand, for right hand, snap out the flap. And then the unit will be installed as a sleeve over the tile. So we install the units as we install the tiles on the roof. They act as a sleeve over the end of each tile on our verge. The first unit we leave whole and install over the eaves closure unit, putting the nail in through the batten end clip, and then moving up the roof as we install each unit, we hammer out the appropriate tab for either the left or right hand side of the roof. You need to make sure that the tabs at the bottom end of each unit engage with the lugs at the top end of the unit beneath, and that they slide nicely into place, allowing for the gauge of the tile. And then line up the holes at the top of each unit with the batten end clip and hammer in with the appropriate fixing to secure it at both the top and bottom of the verge unit. Okay, with our roof mostly installed now, all that's left is the ridge. And we come back to our dry ridge system. If you remember, we've already been to this box to take out our batten straps to fix our batten in place. It's included as part of this pack. We're now going to take out our ridge roll, which is the breathable membrane, which allows our ridge, which we've left open, to breathe through the fleece here, while the corrugated tape on the sides gives us some waterproofing either side of our ridge tile once it's installed. There's a butyl-based sticky strip on the back, which will adhere to the side of the tiles on the roof, which we'll install in a moment. Between our ridge tiles, we also have our ridge-to-ridge seal. This sits between the tiles like so, with a wood screw and clamping plate on top to hold it down in place. Fixed firmly into our well-fixed ridge timber. Removing the cover from the butyl strips at the end of our roll, we position it on our verge system, tucking it under and sticking it firmly in place. We can then roll out the system across the roof, being careful to make a nice, neat line across the ridge. With the profile tile, we can make sure we have a nice aesthetic with the tape by fixing to the top of the roll first, the tile, and then working the corrugated tape into the troughs between those rolls. That way we avoid any kind of handprints, fingerprints in the corrugated tape, which can look unsightly. What we'd like to achieve with this is a nice clear black line which appears underneath the ridge tile going along our roof. Once the tape's firmly in place, with the central part of the tape following our ridge batten from end to end, we can then install our ridge tiles. We've chosen to include a block end ridge on this system to match in with the nice terracotta verge system we already have in place. We're then between those ridge tiles installing our ridge-to-ridge seal. The ridge-to-ridge seal is fixed in place with a wood screw and clamping plate to give the strength to that mechanical fix, which then holds the entire system to the roof. So there we have it. We've installed a basic roofing system, including the tiles, underlay, ventilation, dry fix, ridge system. And if you'd like to know more about how to install your roof, then we have more details available about our 2-day self-build course at redland.co.uk/training.